Hi everyone, notes 4.5 are on transformations of exponential functions. So we filled in all of this information that we have here in class, but there's one thing that I just want to touch upon really quickly because this is going to help us out with the rest of the video. So if you guys remember, we wrote y equals a times f of k times x minus d plus c, and if you notice right here, this f right here is talking about f of x, or it's talking about your rule, okay? And then if we have exponential functions, it's always going to be y equals, like our base function is always going to be the base to some power of x. That is our parent function. So our parent function is going to be b to some power of x, but b can be any base that we want. So right here, for exponential functions specifically, our general equation for a transformed exponential function would end up being y equals a times, now the rule is f, and here the rule is saying take the base and raise it to some exponent of x, but x is all of this stuff inside of here because these are the horizontal pieces, so b times b to the power of k times x minus d, and then this plus c on the outside right here. So remember, these pieces are our vertical pieces, and these pieces here are going to be our horizontal pieces. So for question number 1, it says use transformations to sketch the function y equals -2 times 3 to the power of x minus 4, and then state the domain and range. So the first thing we need to do is identify what our parent function is. So our parent function here is going to be, what is my base? Well, my base is 3 because that's what the power is on top of. So b is going to be my, or 3 is going to be my base of that I have here. So my parent function is 3 to the power of x. And how do I know that it's 3 to the power of x? Because I know it's an exponential function because my x is in my exponent here. And right here I've got 3 to the power of x as my parent function. Okay. So now I want to do a chart for my parent function right here. So x right here, and then p of x, what's going to end up happening when we actually plug in our x values right here. So I'm going to start with -2, and I'm just going to go from -2 up until +2. So if you guys remember, to figure out p of -2, it means I'm going to raise 3 to the power of -2, or in other words, 1 over 3 squared, which is 1/9. So this ends up being 1/9 right here. Okay, p of -1 means 3 to the power of -1, so I'm going to do 1 over 3 to the power of 1, which is just 1/3. Okay, p of 0 means 3 to the power of 0, and anything raised to the power of 0 is always 1. P of 1 means 3 to the power of 1, which is just 3. And then P of 2 means 3 to the power of 2, which is 9. Okay? So I've established what my parent function is. Now the next thing that I want to do is I want to figure out what my actual transformations are. So I'm going to make a list of my transformations. So the first thing that I'm going to notice is that my base of 3 is being multiplied by -2. So -2 right here is my a value, and what this is telling me is two pieces of information. It's telling me that I have a vertical stretch with a scale factor of 2, and it's also telling me that it is a reflection over the x-axis. Okay, and then I also have up here this x minus 4 right here. So that means that I have a d value that's equal to +4, because remember, it's always the opposite sign. This is x minus d, so in order for d to work here, the d has to be +4 to get x minus 4. And what this is telling me is that I have a horizontal shift 4 units to the right. Okay, so now that I figured that out, that's going to help me out with my chart. Okay, so the next thing I'm going to do is I'm going to multiply, because I have an a value of -2, I'm going to multiply my y values by -2. So I'm going to create a new chart, and I'm going to end up getting x here and y here. And because the stretch or the compression is only happening to the y values here, my x values stay the same. There's only an a here, so the x values stay the same. Okay, and then I'm going to multiply all of my y values here by -2. So when I multiply 1/9 by -2, I get -2/9. When I multiply 1/3 by -2, I get -2/3. 1 times -2 is -2, 3 times -2 is -6, and 9 times -2 is going to be -18. Then, so I'm done with this piece right here. Then I need to move my everything 4 units to the right. So I'm going to add 4 to all of my x values, because to the right means that my x values are the ones that are changing. So when I do that right here, and when I add 4 to -2, I end up getting 2. When I add 4 to -1, I get 3. When I add 4 to 0, I get 4. When I add 4 to 1, I get 5. And when I add 4 to 2, I get 6. And then I'm not shifting up or down at all, so my y values will stay the same. So I still have -2/9, -2/3, -2, -6, and -18. Now I need to decide how I want to space out my graph. I think going by ones for my x-axis is probably the most appropriate way for me to graph it out. But for my y values, I want to go down to -18. So I think maybe if I go by 3s for each piece right here, each block, I think that would be an appropriate scale. So this would be -3, -6, -9, -12, -15, -18, and then I can go the opposite way up here with my positive values. All right, so now all I have to do is just graph out my coordinates. So I know that 2 will correspond with -2/9 right here. So it's going to be very small. I'm going to have it go right here, almost touching the x-axis. 3 will correspond with -2/3. 4 will correspond with -2 right here. 5 will correspond with -6, and 6 will correspond with -18. So I know that my graph is going to have the same horizontal asymptote as the parent function does, and we'll talk about why in a minute. So that's what my graph will end up looking like. This is what we'll have right here. Now remember, our parent function will always ends up looking like this right here if we have exponential growth, and it's growth if our base is greater than 1. So if you notice, our horizontal asymptote of our original function was just the x-axis, or y equals 0. And here, all that happened was I reflected it over the x-axis. I stretched it out so it got taller, but I didn't end up, and I moved it to the right 4 units, but I didn't end up actually shifting it up or down. So my horizontal asymptote will end up being in the same spot, okay? All right, so now question number 2, use transformations to sketch the graph of y equals 4 to the power of -2x minus 4 plus 3. So first of all, I know that it's an exponential graph because it's a base raised to a power with the variable in the power. So what I'm going to do is figure out what my parent function was originally. So my parent function has a base of 4, so it's 4 to the power of x. So I'm going to go ahead and make my chart for my parent function right here, and I'm going to look at it from -2 all the way up to +2, just like we did before. And I'm going to find out all my values. So P of -2 is going to be 4 to the power of -2, or 1 over 4 squared, which means I get 1/16. So this here is 1/16. P to the power of -1 is 4 to the power of -1, or 1/4. P of 0 means 4 to the power of 0, or just 1. And then P of 1 equals 4 to the power of 1, which is 4. And then P of 2 is 4 to the power of 2, which is 16. Okay, then I'm going to make my list of all of my transformations that happened in this equation right here. But before I can do that, I need to rewrite my equation here because my k value is not factored out. So that means that my equation should say y equals 4 to the power of, I'm going to factor out a negative 2, and then I end up getting x plus 2 with a plus 3 on the outside right here. So what are my transformations that happened? Well, there's no a value here, which is nice, so I don't have to deal with that piece right there. I have a k value right here of negative 2. So this is going to tell me two different things. The first thing it's going to tell me is that it reflected in the y-axis this time, because it's the k value. Okay, so since it reflected in the y-axis, we know that because it's negative. And then we also know that it has a horizontal compression. And we know that our scale factor is always 1 over k, so it's going to be a scale factor of 1/2. Okay. What else do we know? We know that this plus 2 right here is going to tell us that our graph moved. So this means d equals negative 2. So this is going to tell us that our graph shifted horizontally 2 units to the left. Okay, and then this plus 3 here is going to tell me that my c value is 3. And what that means is that it shifted 3 units up. Okay, now that's really important to know because that's going to tell us where our new horizontal asymptote is going to be, and we'll talk about that in a minute. So if we know all the information, we can go ahead and do our transformations. Okay, so the first thing that I'm going to do is look at my k value right here, and it's going to tell me that I need to multiply x by negative 1/2, because remember my scale factor is a half right here. So in order to be able to do that, my y values are not being compressed or stretched, so I'm not going to multiply y by anything. So I'm just going to go ahead and keep my y values the same. So 1/16, 1/4, 1, 4, and then 16 right here. Okay. When I multiply my x values by 1/2, I end up getting this value is negative 1, or sorry, positive 1, because I'm multiplying by negative 1/2. The negative 1 becomes positive 1/2. The 0 stays 0. This 1 becomes negative 1/2, and this 2 becomes negative 1. Okay? Now that I've done that, the next thing I'm going to do is do my shifting right here. So what this is telling me is that I need to, this pink piece here is telling me that I need to subtract 2 from x, okay? And then the green piece is telling me that I need to add 3 to y, okay? So I end up getting the following values right here. When I subtract 2 from my x values right here, subtracting 2 from 1, I end up getting negative 1. When I subtract 2 from 1/2, I get negative 1.5 or negative 1/2. Subtract 2 from 0, I get negative 2. Subtract 2 from negative 1/2, and I end up getting negative 2.5. And you know what, you guys? Sorry, I'm going to be consistent, so I'm going to keep this negative 1.5, keep them all fractions. And then when I subtract 2 from negative 1, I end up getting negative 3. Okay, and then when I add 3 to all of my y values here, I get 3 and 1/16, I get 3 and 1/4, I get 4. Here, this 4 plus 3 will give me 7, and then the 16 plus 3 will give me 19. Okay, so I'm going to go ahead and set up my x and y axes. So I'll put x here, I'll put y here, I'll put a 0 here. And I think that maybe going by halves for my x values will be an appropriate scale. And just like we did before, I think going up by 3s for each block, for each unit here would be an appropriate scale. So put 6, 12, 18 right here, and then we'll put -6, -12, negative 18 here. So one thing I want to make sure that you guys understand is the original asymptote of any parent function would always end up being at 0. But because this graph was shifted up by 3, that means that my new asymptote will end up being at y equals 3. And let's see what ends up happening when we actually go ahead and try to graph out our coordinates, our new coordinates right here. So our first coordinate that we have here is -1 and then 3 and 1/16. So it's really close to 3. So I'll put it really close to that 3 value right here. Then I have -1.5 and then 3 and 1/4, and it's still pretty close to 3. Then I have -2 and then 4 right here. Then I've got -2.5, 7, and then finally I have -3, 19 up here. So if you notice right here, it's trying really hard to get close to that 3 value, but it just cannot approach that 3 value here at all. So this has my horizontal asymptote right here. For this question, it also asked us to state the domain and range, and I forgot to do that for number 1. We'll do that for number 1 in a minute, but let's talk about the domain and range for number 2. So for my domain, I want to look and see what x values work, or maybe look and see what x values don't work. So any x value that I plug in here will always end up getting a corresponding y value. So x can be any real number. So x is an element of the reals. Now for my range, however, it has all the points will work until I reach a 3, the value of 3 right here. So that means that y is an element of the reals, except y has to be bigger than 3. And because the graph never actually touches 3, we cannot say greater than or equal to 3. We can just say y is greater than 3 here. Okay, as for our domain and range up here, for question number 1, remember this was just our parent function, so we'll get rid of that. Our domain, same thing, x can be any real number, but for our range, y is any real number as long as it's less than 0, because it tries really hard to get to 0, but it just can never touch the 0. So y is less than 0. Question number 3 is still part of our notes, but we're going to talk about that together as a class next time I see you. And that's it. I hope you have a great day. Bye.